Let's try to solve another Leetcode problem. 1612. Check if two expression trees are equivalent. So the expression trees is a kind of a binary tree used to represent arithmetic expressions. So for the first example, that is only a root and with a string x, and for the root 2, it is also the x, so that is equal. Maybe the second example is easy to compare. So inside the expressions, because all this node there is a plus sign, there's no negative or other side, so this makes the problem even more easier to solve. So let's just check the constraints first. So the number of nodes in both trees are equal, so that is okay. Odd, and in the range, so that is also odd. Yeah, because according to the problem, for each of the roots, it's gonna have 2 children or 0 children. So it means in total the number of nodes gonna be odd. And also the node.val is only a plus sign or a lowercase English letter. So for example, it is a plus sign or lowercase English letter. And all the leaf nodes are lowercase English letter. So this makes the problem easier. We just need to count how many leaf nodes. So if the counter of this one equals to the counter of root 2, it means it is okay. So for example, this is ABC, and this is also ABC, and this is ABC, and here is ABD, so that's going to be false. And this is X, and this is X, so it's going to be true. Yeah, so let's just start the basic traversal. So for a node, so we can start any kind of a traversal, it should be okay. Node dot left and DFS node dot right. So this is a basic traversal. So we need to put the values inside. So I'm gonna prepare self.result gonna plus equal to node.value, but we need to have a condition. So if the node exists, and if not node.left and not node.right, this means this is a leaf node. So if it is a leaf node, I want to put it inside the result. As it is a string, so I'm gonna define the self.result as an empty string, and then I'm gonna call the DFS with root 1. So after call it, I'm gonna store it in another variable. It's gonna be self.result1 and gonna be equal to self.result. And similarly, I'm gonna call the root 2. Yeah, so I'm gonna call the root 2, and I'm gonna prepare the self.result gonna be an empty string, and then I'm gonna store self.result2. It's gonna be the self.result. So finally, I just need to check the counter of self.result1 equal to counter of self.result2. Yeah, because there is only the positive sign, and the positive sign will not be the leaf node. And all other characters like ABC are gonna be the leaf node. So we only need to count the leaf node. So if the counter of root 1 equal to the counter of the root 2, it means it is true, otherwise it can be false. As you can see, it works. That means just to submit it to prove it works. As you can see, it works, and it's pretty fast, and the time complexity is ON. Thank you for watching. See you next time.